Hello friend, this question is from the test series number 10. Subject name is analog circuit, topic name is AC/DC analysis. It's a 2 marks problem. Question says that you have a common amplifier with gain beta is equal to 100. Base to emitter voltage is 0.6. If base to emitter voltage is 0.6 and collector to emitter voltage VC is 2.5 volt, then find out the value of R1 plus R3, where R1 is resistor connected from supply to base terminal, R3 is a resistor connected from supply to collector resistor. Okay friend, and the question says that the collector current IC is 1 milliampere. The collector current IC is 1 milliampere. So IC is given to us as 1 milliampere. Friends, we know that IB is nothing but IC by beta. So it is 1 milliampere upon 100, which is 10 raised to the power minus 5 milliampere is your IB. Okay, so IB is nothing but 10 raised to the power minus 5 milliampere. So next thing is IE, emitter current. IE is nothing but IC plus IB. I can write it down it as a 0.01 milliampere. 10 to the power minus 5 ampere or 10.01 milliampere. So IC plus IB, which is my IE, is nothing but 1.01 milliampere. Okay, so now we know that all the three currents of the transistor. Now let's apply KCL in the outer loop of the transistor. Apply KCL in the outer loop. So you will have the equation as 5 minus R3 into IC minus 2.5 minus IE times 300 ohms is equal to 0. We know that IC we have calculated, IE we have calculated. So what is the value of R3? R3 will be nothing but 2.5 minus 1.01 into 0.3 upon IC, which is we have calculated as 1 milliampere or given as 1 milliampere. Okay, so the value of R3 will be 2197 ohm, or I can say it as 2.197 kilo ohm. So value of R3 is given as 2.197 is kilo ohm. So this is the value of R3 we have calculated by the outer loop of the KVL. Next thing is we need to calculate the R1. So again, you know that it is a self bias or potential divided by circuit. What we need to do in the DC analysis, first thing we do, we convert the circuit into its Thevenin equivalent form. What we do, we apply the Thevenin's theorem in the base terminal and we calculate the VTH and RTH in the base terminal of the transistor. So let's draw the Thevenin equivalent circuit, which will be something like this. We will have one RE, which in my case is 300 ohm. Okay, and then we'll have RTH, then we'll have VTH along with a resistor, a collector resistor, which is R3, which we have calculated as 2.897 kilo ohm and 5. This is my circuit. And what is my RTH? RTH is nothing but parallel combination of R1 in 100k, R1 in 10k, R1 parallel 10k will be my RTH, and VTH will be VTH. We can calculate VTH as VTH is equal to 10k times 5 upon 5 plus R1. This will be my VTH, that is 10k times 5 upon R1 plus 10k. Okay, like 50k R1, 50k upon R1 plus 10k. This will be my VTH. Put the value of VTH. You can say that RTH is also 10 R1 parallel 10k, base to emitter voltage 0.7. We know that voltage drop across 300 ohm. We know that IE we have calculated as 1.01 milliampere. In the kilo ohm it will be 0.3 kilo ohm. Okay, so I know the value of so just apply the KVL, which is VTH is equal to IB RTH minus 0.7 minus 0.3 into 1.01 kilo ohm and milliampere is cancelled out. So you can see that RTH is also a function of R1 and VTH is also a function of R1. So in this expression I have VTH is also a function of R1 and RTH is also a function of R1. So in this expression, in this loop, I have only one variable, which is R1. IB we have already calculated as 10 raised to power minus 5 ampere or 0.01 milliampere. So all the other variable we already know that. So the value of R1 by the calculation, the simple calculation, value of R1 will be equal to nothing but the R1 will be equal to 40.97 kilo ohm. 40.97 kilo ohm is the R1 value. So my R1, we need to calculate the R1 plus R3, where R1 we have calculated as 40.97, R3 we have calculated as 2.197. So R1 plus R3 will be, R3 will equal to 2.197 and R1 plus R3 will be 43.047, which basically what we need to do. We have calculated the R1 and R3 individually, then we have added that. How we have calculated R3? We have calculated R3 by applying KVL in the output loop. We have calculated R1 by applying KVL in the input loop. Okay, because in the output loop we know the IC, we know the VCE, so we have only one unknown was there, R3. So we have applied the KVL and calculated. In the input loop also we have calculated the VTH in terms of R1 and 10K. We have calculated RTH in terms of R1 and VTH and 10K. Then we have this one equation and the unknown was only R1, so we have calculated as 40.97. Okay, thank you.